In this next video, kind of the last in this particular series, we're going to talk about the size of your foundation. Okay, just talk the minimum size required by code. And we'll talk about some of the connections that hook up your foundation with the building above. Because remember, one of the functions of your foundation was to anchor the building down into the soil below. So let's talk about foundation size. First of all, let me give you a caveat, okay? This that we're talking about right here is the code required minimum size. It's for light frame, residential construction only. It's for one-story buildings, okay? This is absolutely the minimum size you'll ever have. If you need anything more than this, and even if you need more than this one, you're going to have a structural engineer size your foundations for you. This is not something that you're going to do professionally. Okay, but let's talk about the absolute minimum size required for the foundation. First of all, let's look at the depth. The depth of your foundation is measured from the grade line, the exterior grade, right here, the level of the soil outside your home, down to the very bottom of the footing. Okay, so that's the measurement from here down to here. And the minimum required depth for your foundation by code, remember, is 12 inches below the frost line. The frost line is wherever the soil typically freezes in your area. So it's going to vary depending on where your home is located. If you're here in the Bay Area, surprise, surprise, your frost line is 0. Okay, our soil doesn't freeze ever. Okay, so what is our minimum depth of our foundation? It's exactly 12 inches. It's very, very shallow. Okay, if you go somewhere else, for example, if you're working up in the Tahoe area, if you're working in the northern part of the US, if you're working somewhere else where they have, they actually get, frozen ground in the winter, okay, your foundations will need to be deeper because they need to go at least 12 inches below that frost line. Okay, so that's the minimum depth of your foundation. Now let's talk about the width and the size of it. And turns out there's a bunch of different measurements, but they're all related to each other. And the first one I'm going to talk about is this right here, T. Okay, T is 8 inches minimum. That's a code required number. Okay, and it is both the thickness of your stem wall right here, or your foundation wall, so T, and it's also the thickness of your footing. Take a look at that. This is dimension right here is also T. So that's going to be a minimum of 8 inches. This dimension right here, which they're calling P, is required to be half of your T, or half of your thickness, for a minimum of 4 inches. Okay. I like to think of P as kind of the shoulders of your footing. For some reason, that makes sense to me. Okay, so these shoulders right here have to be half of the thickness of your foundation wall. And the final dimension here, W, for some reason right here, okay, the width of your footing has to be a minimum of 2 times the thickness of your foundation wall. And so that ends up to be 16 inches minimum. I'm going to wrap up this discussion with talking about the connections from the foundation up into the floor and wall systems. Remember that one of the functions of our foundation was to anchor the house down into the soil. Okay, and we here in California know that that's very important because in an earthquake, our house could fall off of its foundation. If we lived in hurricane country, it could also be lifted up off the foundation. Okay, so this is very important to connect our foundation. And there's two tools for doing this. One is called an anchor bolt, and the other is called a hold down. And I'm taking a look here at the Building Construction Illustrated textbook, and here is a diagram. This one right here is the top of the foundation wall, okay? And that could be a basement wall, it could be a crawl space wall, it could also be the girder that goes across the top of a series of piers. Okay, so whatever the top of that foundation is right here, here is the pressure treated sill plate sitting on top of that foundation. And this piece is an anchor bolt. An anchor bolt is bolted right here on top of the sill plate and extends down into that concrete foundation wall and holds it firm. Here's another illustration of the same thing. Okay, here's the top of that foundation wall. Could be the stem wall right here. Here's the pressure treated sill plate sitting on top. And the anchor bolts extends into the concrete and really holds the structure above, the wooden structure, firmly into the concrete. That's its function. This piece is a hold down right here. A hold down connects from the wall above. Notice that the anchor bolt doesn't connect to the wall above. Okay, the hold down connects to the wall above and pulls it down and connects to this floor system and then into the structure below. I'll show you another picture of it. Here we go. So what's the difference between anchor bolts and hold downs? They serve two different purposes, similar but different. Okay, anchor bolts right here. And here's a picture of them. When we cast that concrete foundation, we actually cast the anchor bolts into it and then put the wood structure on top of it later. Okay, so anchor bolts, they resist side-by-side forces, lateral forces, that could cause a building to slide off its foundations. Okay, so that could be, for example, an earthquake could cause the whole house to slide right off its foundation if you don't have those anchor bolts. Hold downs right here are this metal piece right here. See this? This is the hold down, and it also includes a bolt that goes down into the foundation, okay, which is why these two things look very much similar. But take a look, it's got this piece right here that connects up into the wall system. This is a wall stud. So here's a hold down right here. And here is the metal piece that's connecting into this wall. And then right here is the bolt that's going down into the foundation. So hold downs resist forces that could cause the building to lift or kind of twist up and off. All right. Anchor bolts, hold downs, they're connecting the home to the foundation system above, and you really need both of them. All right, so in this lecture series, we talked about foundations, what they are, why we need them. We talked about the 4 very common types of foundations, and you learned that we actually can mix those types even within the same house. All right, and finally, we talked about kind of a minimum code required size for foundations and how we connect the foundations to the house above. Thanks, everyone.